Hello, KringleCon, and welcome to my talk, Pivoting with SSH. My name is Rook, and I'd like to thank everybody for coming all the way up to the North Pole, and a special thank you to Santa Claus for bringing all the hackers together to, make sure that Christmas moving forward is a safe and relatively frictionless event, unlike some previous years. So we've got a lot to cover, so let's just jump right into it. First of all, you may be asking yourself, why are we talking about SSH in a hacking conference? Why this is remote administration work? And that's true. Maybe you want to use SSH pivoting or port forwarding for some remote administration. But also, if you're on an engagement and you need to access some protected networks, you're able to get a foothold on one system that's inside a protected network. You can use this technique to pivot to the rest of the network and start attacking some of those protected hosts. Additionally, some administrators like to put services on local host only bindings, so they only listen to the local host address, and we can use SSH pivoting to attack those services as well. And as we move through the techniques, I have some demos to show exactly what I'm talking about here. Our first technique is going to be called local port forwarding, and we tell SSH that we're going to do that with a -L. And we'll walk through the rest of the syntax here just to give you a brief overview, and then we'll also give you, I have some demos in just a second. So after we tell SSH that we're doing local port forwarding, we then put the port on our local machine that we're going to forward. So this will be the one that we connect to on our local machine. Then we tell SSH what host has the port we want to get to, that we want to attack. And when we're doing local port forwarding, something interesting to know here is that this host is in relation to your pivot host. So if you use localhost here, this is actually the host it's targeting localhost on the machine you're SSHing to. So then we have our target port, that's the one we actually want to attack or connect to, and then our pivot host, this is the host we'll actually be SSHing to. And as I mentioned, I have some demos here, so we'll jump right into the first one. And here I have two bash windows that are on my local machine, and then I have two bash windows that are on a remote machine. And as you can see on the remote machine, I have a HTTP server that's bound to the local host. So it's not running to where I can hit it from outside. And I ran an LSOF to kind of prove that, yes, Python 3 is listening only on localhost. So if we run an nmap on this host, we actually see that port 80 is filtered, which is what we'd expect. But we can SSH and forward a local port, and we'll forward 8080 to, and remember, when we're talking about local port forwarding, if we put localhost here, we're actually referring to the destination server. I need to put my passphrase in for my key, and now we're SSH'd in. So what's happening is we still can't hit it directly, right? We still don't have access to port 80 from the outside. However, if we curl localhost, remember we're forwarding a local port here. We're forwarding port 8080 on our local port to 80 on the remote host. Can actually hit enter, and here's our welcome to KringleCon, it's time to party message with true party fashion. It's blinking and everything if we open this up in a web browser. So that's local port forwarding. Let's jump right back into the presentation here, and we'll talk about remote port forwarding. And some people call this reverse port forwarding. It acts kind of like a reverse shell, but we'll discuss it a little bit. Now this gets a bit brain bendy, so stay with me through the explanation of the syntax, and then we'll jump into another example to hopefully make it a little more clear. So we use a -R to tell SSH that we're remote port forwarding. And this R port, this is how remote port forwarding works. We're going to forward a port on the pivot host, on the host that we're actually SSHing to. We're going to forward a port on that machine to a host and port that our initiating client can access, okay? And maybe you're not quite seeing why you would want to do this, but I'll show you in just a second. So this is the remote port that we're going to forward from the pivot host. This is the host that we're targeting, and when we're forwarding remote ports, this is from the perspective of our initiating client. So if we put localhost in the target host, that's localhost on our initiating machine, okay, not on the pivot host. It's opposite of the way local port forwarding worked. It doesn't have to be localhost. It can be any host that our initiating machine can hit over the network. Target port's the same thing. That's the port that we're trying to get the port forwarding to forward to. So if we do localhost on our target host, then maybe we're trying to get it to our local port 22 to SSH locally, and then the pivot host, the SSH host again. And now that you're thoroughly confused, let's bring this home with an example. So let's imagine that before you left for KringleCon, we're working on something at home, or you've got a server running at home, you've got some home automation, maybe you have a doorbell camera that you don't have on the internet but you want to monitor while you're away. But at home you don't have a static IP address, you don't have a VPN set up to VPN directly into home. So what do? Well, you can, if you have a remotely accessible server like I do in the quote-unquote cloud, you can use remote port forwarding to forward a port on your remote machine back into your local machine, even though it's behind a firewall, because you're actually connecting out to it from behind the firewall. So that's why a lot of people call it like a reverse port forward, or like a reverse shell, because it kind of operates like one. So we're going to forward port 2222 on the remote machine to localhost port 22, and there's a remote machine. So this is the same syntax we saw before. We hit enter, authenticate to the server, and now it's running. Now, for as long as this SSH is open, as long as this connection is valid, over here on our remote server, we can SSH root at localhost, because we're forwarding an IP or a port on the remote host, this local host, to port 2222. Okay, so we're SSHing to ourselves. Actually, I can show this another way. If we SPI 2222. Oop. Oh, whoops. We can actually see that we're listening on port 2222 now. Okay, so this is us. SSH itself is listening on port 2222. So we can SSH to localhost, root at localhost, because Callie doesn't know about users, and we'll SSH to 2222. And we type in the super secret root password. And here I am on my local machine. So anywhere, say from here at KringleCon, that I can access my remote server in the cloud, I can actually SSH back into my local network at home and do any sort of work that I needed to do, or check, the camera doorbell, or whatever I needed to do. So that is extremely handy. Let's back out of this. We'll jump back into our last, our second to last type of pivot. Now, this is extremely helpful. This is actually a proxy jump host. Now, what this does is, imagine a time, which I'm sure none of you have had to do, where you wanted to get to machine 5. But in order to get to machine 5, you had to SSH into machine 1, and then SSH into machine 2, and then 3, and then 4, and then finally you could get to 5, because they're all on different networks and they all only have like access to each other, right? We can actually use jump hosts to simplify that process. Okay, so we use a -J to tell SSH that we're going to use a jump host, and we specify the intermediary SSH server that we need to get to. This is just the one that we have to bounce through. You can think of it similar to a web proxy, except this is, you're just jumping through, you're just proxying through an SSH server. And then the eventual host that you want to get to. As always, we've got a demo, kind of drive this home. Now, there's a couple things I want to point out here. So we have our local boxes here, and I know this is a little hard to read because I'm trying to keep the font big enough for the people in the back. But we have our local machine here. We have a jump 1 box here, okay, and it doesn't have any IP table restrictions. Jump 2, however, will accept only connections from SSH connections from jump 1, and it'll drop any other SSH connections coming into it. So only jump 1 can access through SSH jump 2. And then on jump 3, we have something similar. So it'll only accept SSH connections from jump 2. It'll drop any other SSH connections. Another interesting thing is that it actually can, it's going to accept any HTTP connections from jump 2, but it'll drop any other HTTP connections from anywhere else. So it's likely that there's an HTTP server running on this, but only jump 2 can access it. So what do we do about that? Well, we can, using the proxy jump command in SSH, we can actually do a jump 1. And something neat about proxy jump is you can specify subsequent jump servers. So you don't necessarily, here I'll expand this so that it's all in one line. You don't necessarily need to have multiple of these jump commands. You can just say, I want to jump through jump 1 and jump 2 into Rook at jump 3. And it'll force you to log into each one in a row. And jump 3 always takes an extra minute here. This is always when you start praying to the demo gods. And now you're into jump 3 with one simple command, right? But what about, but what about that HTTP server? Well, we can actually, we can do something cool and actually chain these commands. So we can use a capital minus or a minus capital J to invoke the proxy jump. And then we can actually use a minus capital L to port forward our 8080 to jump 3 on 80. So this is a little more complicated, but we've already done all of this before. So we're using jump 1 as a proxy host to jump into, to get to jump 2. This allows us to get into jump 2. Now that we're SSHing into jump 2, we can forward our port 8080 through jump 2 at jump 3's port 80, okay? And then we have to authenticate like we did before. Now our local port forward is set up. So we can come here, and if we, same thing we did last time when we did the zero or the local port forwarding stuff. If we curl ourselves on port 8080, open this up, that is getting locally port forwarded to jump 3. And it's a little slow because you're pivoting through, you know, a couple different SSH connections. But now we get our jump hosting insanity web page. Okay, can you believe this stuff works? This is crazy. This is voodoo. Well, we're not quite done yet. Actually, we have one more tactic here that I'd like to teach you, and I saved this one for last because a lot of people consider it the most useful one. It's also the least difficult to kind of comprehend. And this is basically setting up a dynamic port forward, or setting up a port as a SOCKS proxy. Okay, so we use a capital D to let SSH know that we're going to do this. We're going to set up our proxy port, and then we're going to set up our pivot host. Okay, and that's just our local port on the initiating client that that is going to be our proxy port. So we can do the previous demonstration a little bit differently. So if we SSH jump into through Rook at jump 1, and then we dynamically port forward all 8080 traffic through Rook at jump 2. Okay. And then we authenticate. Oops. Typos. We authenticate. Everything's groovy. We come down here. Now, instead of having to curl localhost like we did before, we actually have a proxy server set up. So we can proxy, like I said, it's a socks proxy. So in curl, we use a -x to denote what our socks or what our proxy server is going to be. You can also use a web browser, just point your web browser to this port. But we can use a socks proxy. We're going to proxy everything through this port setup, which, as we saw in our previous command, that port is being forwarded through jump 2. Okay. And then we're going to do HTTP jump 3. And there's that server again. There's that page again. So if you don't believe me, we can nmap directly. We can nmap direct. Oh no. Okay, there we go. We can nmap port jump 3 directly too on port 80 and show that it's still filtered. So the only reason we're able to get this page is through that dynamic port forward. All right, it's time to wrap up. I know there's a lot of other very interesting talks going on at KringleCon that you want to get to. Just a couple references here. Resnock has written an amazing SSH tunneling tutorial with graphics to help you understand the examples he's using and a little more in-depth use of the different flags. And then I also have started a pentest process wiki. It's a little slow moving because I only remember to update every once in a while, but I do have a fully fleshed out SSH tunneling reference on that. So you can visit my GitLab and go to that wiki, and there's a pretty great SSH pivoting reference. I'd like to thank you. I'd like to thank again Santa Claus for inviting all of us out here and just really furthering security as an industry. You can find me on Twitter at _R00K_. I'm also on YouTube. I've got a blog, and then my GitLab is somewhat active. So thanks again.